Good morning, everyone. In this lecture, EC8652 Wireless Communication, Unit-1 Wireless Channels. In last sessions, we are discussed the large scale fading effects and also the link power budget design analysis. Now today we are going to discuss about the topic time dispersive parameters. The time dispersion parameters are help in qualifying the different multipath channels. So that is it is possible to compare the several multipath channels. The following delay profiles are multi-channels parameters that have to be measured accurately. So number one, what are the different measurement? Number one, we can find out the mean excess delay and RMS delay spread and excess delay spread. In these dispersion properties are considered with respect to the wideband multi-channels, that is called wideband multipath channels, and they are qualifying by the RMS delay spread and mean excess delay, that is denoted as dou. This RMS delay spread is given as a root of dou square minus dou whole square. So the RMS delay spread is nothing but the square root of the second central moment of the respective power delay profiles, and the means excess delay is nothing but the first moment of the same power delay profile measurement. So we can analyze the environmental in the frequency and RMS delay spread. In the environmental of urban and suburban and indoor propagations, we are the RMS delay and the frequency we are different ranges. So we can find out the values of RMS delay spread and indoor power delays profile. The mean excess delay measurement does not depend on absolute power level. Okay, so but it depends on relative amplitude of the received signal, that is detected first at the receiver end. So the RMS delay spread values will be in a nanosecond order or estimated in outdoor environmental. Now we can see the delay are measured relative to the first detectable signal arriving at the receiver at the maximum excess delay x of dB of the power delay profile is defined to be the time delay during the multipath energy falls to x dB below the maximum. So we can find out the RMS delay spread and mean excess delay are defined with respect to the single power delay profile with a partial average of close impulse response. It is observed with the respective local areas. Now the time delay in which the multipath energy would falls to x decibels, the maximum value is defined as a maximum excess delay. Okay, we can understand. That is the time delay in which the multipath energy would fall to x dB, that is a x decibel. The maximum value is defined as a maximum excess delay, that is called a maximum excess delay. This maximum excess delay also defined the temporal extent of the respective mobile signal, that is called a multipath specific threshold value. it is important that the threshold has to be related the maximum received multipath to the multipath noise floor value. Thus, these time dispersion parameter mean excess delay and also the RMS delay spread and also the excess delay spread or maximum excess delay are the main factor used to compare and estimate the performance of various multipath channels. And also these delay parameters deal with the time domain frequency signals. Now we can move to the RMS delay spread. That is I would like to already I say the root of tau square minus tau whole square. So the typical value of the RMS spread are on the order of microsecond in the outdoor mobile radio channels and also the order of nanosecond in the indoor radio channels. Now we can move to the CoCurrent bandwidth. The CoCurrent bandwidth to help characterize the mobile channels in frequency domain, it is inversely proportional to RMS delay spread value. The CoCurrent bandwidth is basically a statistical measurement of different frequencies. Okay, it is a statistical measurement at a different frequency for which the radio channels is observed, that is a flat type. In this flat region, the radio channels passes the entire spectral components that has to nearly equal gain value. That has to nearly equal gain value and with near space value. So what about the CoCurrent bandwidth are estimated? That is a BC is equal to 1 divided by 50 into average RMS delay spread. That is a dou is nothing but the average RMS delay spread. In this relationship, what are the relationship? 50 to tau and the 50% correlation is a 1 divided by 5 to tau. In this relationship between the RMS delay spread and the CoCurrent bandwidth is a function of channel impulse response. And it is related to the CoCurrent bandwidth or sometimes termed as a ballpark estimations. So this bandwidth, that is a CoCurrent bandwidth, that depends on frequency correlation functions. So the CoCurrent bandwidth for envelope of and for space of the particular transfer function are measured. But the CoCurrent bandwidth is very important measurement for noise limiting systems, because the space is calculated theoretically but it measured in real time environment. Okay, we can understand the CoCurrent bandwidth. Okay, now we can move to the Doppler spread and CoCurrent time. The time dispersive nature of channel. The time dispersion nature of channels in a local area is described mainly by two parameters. Number one, CoCurrent bandwidth and also the delay spread. But the time varying nature of the channel in small scale region is described by the parameters Doppler spread and CoCurrent time. The Doppler spread is denoted as a BD and it defined as a set of frequencies over which the Doppler spread at a receiver end. At the receiver end is a non-zero value. For example, if a pure sinusoidal tone of frequency at a transmitter and it is denoted as a FC, and also the received signal spectrum is called a Doppler spread spectrum consisting of components in the range of Fc minus Fd to Fc plus Fd. That is a positive or negative cycles. In where the Fd refer to Doppler shift frequency, so the total amount of spectral will depends on the Doppler shift, that is a Fd plus Fc. Now, if the bandwidth of the baseband signal is higher than the Doppler spread, then the effect of Doppler spread will be very less at the receiver, and such a type of channel is rated as a slow fading channels. So the parameters CoCurrent time and Doppler spread are inversely proportional to each other. So the CoCurrent time, that is a Tc is equal to 1 divided by Fm. Fm is nothing but maximum Doppler shift, and Tc is a CoCurrent time. That is called a delay spread and CoCurrent bandwidth, and delay spread and CoCurrent time. So in this CoCurrent time is a 1 divided by Fm, that is a maximum Doppler shift, and Dc is a CoCurrent time. The time is statistical measurement of time duration, which the impulse response of the channel is invariant. If the CoCurrent time of channels is lesser than the reciprocal bandwidth of the base signal, and then the probability of occurrence of the noise at the receiver is high, so it considered the CoCurrent time is nothing but the time for which the time correlation function. So that time correlation function is greater than the 0.5 correlation time. So the Tc is equal to 9 divided by 16 pi Fm, that is a maximum Doppler shift. So this maximum Doppler shift Fm is equal to V divided by lambda. Here the V is indicated as a velocity, and a lambda is referred to the wavelength. Then the quality of signal thus depends upon the CoCurrent time factors. So in this lecture, we have to discuss the time dispersion parameters of mobile multi-channels, and also the CoCurrent bandwidth, and also the Doppler spread and CoCurrent time in the multi-path channels. Thank you for watching this video.